Hey, what's up guys? Welcome back to the channel. So today we're looking at this lead code problem which is called linked list cycle, right? So the objective is pretty simple. You're given a linked list and you're asked to check whether the linked list contains a cycle or not, right? So in case you didn't know, a linked list is a linearly ordered chain of elements where every element contains a next pointer to the following one, and ideally it should have ended at the 4 right here, but the 4 has a next pointer which points back to 2, or it could have been 0 or anything else, but ideally it should have been null. The next pointer should have been null. So the question is, how do you know if a loop exists in your linked list or not, right? So the first approach to solving this is actually pretty easy. So when we think of a linked list, we usually think of, so here's the definition of a list node, as you can see in the code here, int val, right? So you would think of getting the val of every node for your calculations, but we can do this in a very simpler way, right? We could just make a hash set of type list node, right? And what I'm gonna do here is essentially I'm going to traverse the whole list, right? So while head not equals to null, right? Let's say that, and then I'm gonna iterate over the whole list, right? So the result type is boolean. So this function basically returns whether it returns whether the linked list has a cycle in it or not, right? So now here's the thing. What we're going to do is we're going to check if set contains the list node, right? So it's very simple. Instead of putting the value of 3, 2, 0 and -4 in the hash set, we're going to put in the nodes themselves. So we're going to put in the address of node 3, the address of node 2, 0 and -4 in the set. So if a loop occurs, the address should already exist in our set, so we should be able to catch it like that. So we are storing the addresses of the nodes themselves, like the node objects, and not the values, right? So we're gonna do if set dot contains head, right? So that's how you know that you found the loop. Return true. If that doesn't happen, so you could say else, else set dot add head, right? So you add it, and then we're gonna do head equals head dot next, right? This should work, I think. Let's run this. Compile. Oh, my bad. Missing return statement. Turn false. Right. Okay, so it worked. Let's try and submit. You can't see the buttons. Okay, so it worked. You can see the stuff on the screen. So runtime 8 milliseconds, faster than 10.25% of all Java online submissions, and memory usage 48 megabytes, less than 5.54% of all Java online submissions, right? So it worked, right? And it worked, but there is a space complexity of, O of n, kind of, because you're making the hash set, and time complexity is technically kind of also O of n, because you're running the thing around in a loop, right? But the point I'm making this video for is that there's actually a smarter way to solve this problem, and it's actually kind of genius the way they do it, right? So here's how you solve the problem. We're gonna use this algorithm called Floyd's algorithm. What Floyd's algorithm does is it's actually a kind of genius approach, right? So what it does is it has 2 pointers, right? It has 2 pointers which are initialized in the beginning of the list, and the 2 pointers run at 2 different speeds. So one pointer runs at twice the speed of the other, right? So the general intuition behind Floyd's algorithm is that if you had a circular track, like a circular running field, right, and you had 2 people running on that track and they had 2 different speeds, right, if they were running for long enough on the track, right, so if they run for long enough on the track, they're eventually gonna meet. So the guy who's faster is eventually gonna loop around or complete a whole loop around the guy who's slower, and he's gonna catch up with him. So the idea is to basically check if the 2 pointers at any point of time meet each other or not. So they're running at double the speed. Imagine there is a tortoise and there's a hare, right? The hare runs at 2x the speed of the tortoise and loops around. If at any point of time they are at the same point again, right, it means that a cycle exists in the linked list. So I'm gonna go ahead and code this out really quick. And okay, so this one is actually extremely simple. So we need a list node, let's say slow equals head, right? We want them to start from the same place, and we're gonna get a list node fast equals head, right? So we want both pointers to kind of start, and they're gonna go around in a while loop, and we want to see if at any point of time they meet, right? So we want to see at any point of time if they meet, right? So it's quite simple, right? What we're gonna do is we're gonna do while fast not equals null, right? Because the fast pointer is the one who is likely to reach the end of the linked list faster. So if you had a straight line and not a loop, the fast pointer would reach the end and just stop, right? So that's your end condition when one person finishes the race, right? So when fast, so you can't really finish a race if it's a looped linked list, so we're gonna exit out of that condition accordingly. So yeah, we're gonna do while fast not equals to null, right? So we're gonna do, I could actually do fast dot next, because I can see a potential problem there. Yeah, so we're gonna do if fast equals head, if fast equals slow, really, if they are at the same position, we return true, right? We're gonna do fast equals fast dot next, which means the fast pointer just doubles in speed, so it skips one, right? So it goes twice, it goes 2 steps in one time cycle, and there we're gonna do slow equals slow dot next, which is the slow one which just goes 1 step in one time cycle, right? And we're gonna do turn false here. Okay, so I fixed it, right? Essentially, yeah, slow and head are both slow and fast are both head, and it's just that in the while loop, you check if fast is not equal to null and fast.next is not equal to null, because you're gonna do fast.next, and then you increment both by this by 2 and this by 1. If they're the same thing, then you found a cycle, return true, and if you don't find a cycle, return false. That's it, right? So we're gonna submit this and see what happens. So this is actually, the runtime of this is actually 1 millisecond, and it was faster than 46.24 of Java submissions for online, and the memory usage is 45.4 megabytes, right? I'm a little disappointed because I just ran this like a second ago and I had faster than 100% for the exact same solution. So yeah, all right. So what's happening is if it's 1 millisecond, then it just rounds up to a whole number and you're less than 46%. But if it's less than 1 millisecond, it counts as the runtime is 0 milliseconds. And so if it's 0, you're faster than 100% of all Java submissions, because you've literally, I mean, this is like an impossible time, right? Well, anyway, the point is you have 2 pointers, one is slow, one is fast. The ratio of the speeds are 1:2, and this is how you find a cycle. It's pretty cool. And this similar strategy can also be used to solve another linked list problem called middle of a linked list. So the problem is you're given a linked list and you're asked to find the middle element of a linked list, right? The question is, how do you do that, right? In O of n time, you could do something like find the length and then find the element in the middle and then traverse that and all of that. You could do that. That's like slightly more, that's also O of n, I guess. But you could do a much smarter thing using the same approach, which I just talked about, which will be faster. What you would do is you would have 2 pointers, a slow one and a fast one, and you would start them off at the beginning of the list. And then when the fast one reaches the end, you would return the value at the slow one, because since the slow one is half the speed of the fast one, it will reach half of the linked list while the fast one reaches the end, right? So this one would be technically O of 0.5n, right? Because it's faster, but still O of n. Yeah, so you could also use this approach to find the middle of a linked list. It's extremely simple and it's cool. If you look at the solutions page, this particular algorithm is called Floyd's cycle finding algorithm. You can Google it, check it out on Wikipedia if you want, and yeah, that's basically it. It's super simple and super fast algorithm, and if you've never thought of it, it's kind of genius, in fact, which is why I'm making this video. So if you enjoyed it, leave a like, subscribe. That's been it for this one, and I'll see you guys in the next video. Have a great day.